In this video, I'm going to cover one of the basic instrument known as infrared spectroscope, and this instrument is a basic instrument of inorganic and organic chemistry. Infrared spectroscope is an instrument which is used to investigate or which is used to identify a functional group or a bonding between inorganic or organic molecules and chemicals. So this instrument basically gives us information about the unknown functional groups exist in a chemical material, either in a molecular form or in a chemical compound forms. The technique which is used, or the technique which is based on infrared spectroscope, is known as infrared spectroscopy. The student, infrared spectroscope is a device, is an instrument which is based on three basic parts. First part of infrared spectroscope is known as IR source region. Second part of infrared spectroscope is known as sample holding region. Third part of infrared spectroscope is known as IR detection region. So dear student, the infrared source region is a region in which infrared source is placed. So infrared source in infrared spectroscope generate infrared radiation and which travel along the forward direction toward the sample holder, like this. These infrared radiations have a wavelength in a range of 750 nanometer to 400,000 nanometer. So infrared radiation in infrared spectroscope fall on a sample holding region. Sample holding region is a region in which a sample is placed. Sample used in infrared spectroscopy is usually in a form of a liquid, solid, or gas. So infrared radiation in infrared spectroscope fall on the sample which is placed in a sample region. The sample used in infrared spectroscope is an organic or inorganic chemical, so they have a specific bonding. Infrared radiation interact with the bond of the chemical, and due to interaction of infrared radiation with a bond in a chemical, the bond, basically infrared radiation cause a vibration in a chemical bond, and due to this a specific wavelength of infrared radiation is absorbed by a sample, whereas the rest of the IR radiation will move and will be detected by a detector in a form of a transmitted radiation. So, on the basis of absorbed and transmitted infrared radiation, infrared spectroscope generate a spectrum. And on the basis of a spectrum and on the basis of a absorption of infrared radiation, or on the basis of absorption of a specific wavelength of an infrared radiation, and on the basis of transmission of the infrared radiation, we generate infrared radiation spectrum, and on the basis of that, functional group and as well as bonding in a chemical compound or in a molecule is determined by infrared spectroscope. So now let dear student discuss step by step essential part in infrared spectroscope and how we can analyze a sample in infrared spectroscopy. Distant infrared spectroscope consists of infrared radiation light source. In IR spectroscope, there are four basic types of infrared radiation light source are used. First type and most common type of infrared light source used in IR spectroscope is known as Nernst Glover lamp. Second type of IR source used in infrared spectroscope is known as Glover lamp. Third type of IR source is known as nichrome coil or incandescent wire. Fourth type of radiation, fourth type of infrared radiation used in IR spectroscope is known as vacuum mercury based vapor lamps. Now the key point to notice here is that the IR spectroscope most commonly Glover lamp is used. Let us discuss step by step all the four types of IR source devices. Nernst Glover lamp is usually based on rare earths metal oxides. Most commonly rare earth metal oxide on which Nernst lamp is made are cerium, lanthanums such as yttrium, scandium, neodymium, gadolinium, etc. Now question is that why the IR source is made with a rare earth materials. Basically, student, the temperature of rare earth oxides are usually higher than 750 degrees centigrade, and it may go up to 1650 degrees centigrade and even more. So the melting temperature is of these rare earth oxide is quite high, and due to a higher melting temperature, these oxides do not interact or do not causes a pollution in the system, and secondly they just get heat up, and due to their heatness or due to their high temperature they basically generate electromagnetic radiation in the range of infrared radiations, which is 750 nanometer to around 400,000 nanometer. Second type of infrared radiation source used in IR spectroscope is known as Glover lamp. Glover lamp is based on silicon carbide, and these lamps produce IR radiation due to thermal heating. when electric potential is applied on silicon carbide lamps. The electric potential generates IR radiation due to thermal heating. Keep in mind that silicon carbide are also uh, have a higher melting temperature, and that is the reason they are used in IR. They are used as a IR source material. The silicon carbide used in IR source is in a form of uh, silicon carbide rod. The length of a silicon carbide rod is around 20 to 50 millimeter, whereas the width of silicon carbide rod is around 5 to 10 millimeter. So, dear student, the silicon carbide is used as a source material, is used as an IR source material, and it's produce IR radiation around by when it is electrically heated around 1000 degrees centigrade to 1600 degree centigrade. So the another thing to notice here is that the globe or lamp is combined with a downstream variable interference filter. So basically that interference filter is connected with a globe or lamp, and that interference filter will filter out IR radiation from the global lamp. Since you know that the global lamp is basically heated around 1000 to 1600 degrees centigrade, so there is a possibility of wide range of electromagnetic radiation produced by a global lamp. So interference filter basically its control, and it produce the or its limit the electromagnetic radiation in a range of infrared radiation wavelengths. So apart from this, there are incandescent kind of wires or coil are also used in infrared spectroscope, but they are very limited. Usually, commonly the nichrome wire or nichrome coil are used, and these coils are basically the electric potential are basically applied across these coils, and due to an electric potential and thermionic emission, they basically generate an infrared radiations. Apart from this, there are also mercury-based vapor lamps. They are also used in IR spectroscope. But keep in mind, dear student, nowadays most commonly the globe or lamps which are based on silicon carbide are common in infrared spectroscope. Since the infrared spectroscopes, IR radiations are used to detect a functional group. Now, in infrared spectroscope, these IR radiation from IR source region will move along the forward direction. Infrared spectroscope consists of another device which is present near the infrared light source, and this device is known as an optical chopper. Optical chopper is a mechanical device which is used to split or which is used to divide the infrared radiation into two equal parts. This device will divide the infrared radiation into part 1 and part 2. Student, keep in mind optical chopper work on modulation of frequency, and on the basis of frequency this device divide the infrared radiation into two equal parts, part 1 and part 2. And when the optical chopper divide those infrared radiation into two parts, then these infrared radiations are then moved along the forward direction toward another device known as monochromator. Before reaching to the monochromator, the infrared radiation from optical chopper will pass through two reflective mirrors like this. The reflective mirrors will reflect the IR radiation along or toward the device known as monochromator like this. And then this IR radiations, which are splitted by optical chopper and reflected by a mirror, will fall on a device known as monochromator. Distinct monochromator is a device which converts the multi-wavelength, different types of wavelength of IR radiation into a single wavelength IR radiations. There are different types of monochromator used in IR spectroscope. One of the most common type of monochromator used in IR spectroscope is known as diffraction grating based monochromator. Diffraction-based monochromator is a device which is composed of a diffraction grating. Diffraction grating is a slit which is at a time divided into millions of parts, and these parts are equidistant. So IR light, which constitute of a multi-band light, or which consists of many wavelength of IR radiation, they they will fall on diffraction grating, and these diffraction grating will basically divide, or will basically split the multi-band radiation into a single wavelength of IR radiation in a monochromatic device. Another second type of monochromator which is commonly used in IR spectroscope is based on prism-based monochromator. Prism-based monochromator consists of a prism, so IR radiation of multi-band basically will interact with a prism, and prism basically split it into its component, and then at the end of the day, with monochromator, a single wavelength of IR radiation is achieved. Third type of monochromator used in IR spectroscope is known as filter-based monochromator. This filter-based monochromator consists of filters. So filter basically it will filter out the different wavelength of IR radiation, and instrument of this monochromator is adjusted up to at a specific wavelength. So on the basis of this we can basically achieve single wavelength of IR radiation in infrared radiation spectroscope. So these are the three main types of monochromator used in infrared spectroscopy. However, keep in mind that diffraction grating based diffraction grating based monochromator are most commonly used in infrared spectroscopy. So this is basically first part, which is known as IR source region of spectroscope. So IR source region of spectroscope consists of IR radiation source, optical or mechanical chopper, some mirrors for deflection of infrared radiation, and a monochromator, which basically convert a multi-band of IR radiation into a single wavelength of IR radiations. Now, dear student, let's discuss about the second part of IR spectroscope. Second part of IR spectroscope is usually based on sample holding region. It consists of a reference sample holding region or reference sample holding part, and it also consists of a sample holding region or the region of which is used for a sample which we want to analyze. So in IR spectroscope, the infrared radiation which are splitted by a beam chopper and they are deflected and moved from monochromator will fall on a reference region and they will also fall on the sample which is present for the analysis. The student, please keep in mind the sample reference sample which is used in IR spectroscope they are usually known. So their absorption wavelength and as well as their transmittance wavelength are usually known. Whereas the sample which is under analysis, we don't know about their absorption and as well as transmittance wavelength. So the infrared radiation will fall of specific wavelength will fall on the reference and as well as the region in which the sample under analysis is present. And then when the infrared radiation is fall, then this infrared radiation will be transmitted from both from the reference sample region and as well as from the analysis sample region. Just to keep in mind that usually the reference sample used in IR spectroscope they give 100% transmittance to the infrared radiation which we are use. So we basically they have a known kind of absorption and as well as transmission, and usually the chemical or solution used in a reference sample they don't transmit or they don't absorb the infrared radiations. So we know the intensity and we know the range of the wavelength basically which is of IR radiation which are basically transmitted by the reference sample. Whereas in case of sample which is under analysis in IR spectroscope, they absorb some of the wavelength. So the absorbed wavelength is not known, okay? So and whereas they will transmit the rest of the wavelength of infrared radiations. Now, question here is that why the sample absorb or sample molecule absorb the infrared radiation in IR spectroscope. Basically, the molecules have a specific type of bond between their atoms, and when infrared radiations fall on the bonds of those molecules, they will result into vibrations. They will cause a vibration. It may be in a form of a stretching or bending. So this vibration is a result of an absorption of a specific wavelength of infrared radiation. So rest of the infrared radiation, which is of different wavelength, will move along the forward direction in IR spectroscope in a form of transmitted infrared radiations. So now the transmitted and as well as the from transmitted infrared radiation from the reference sample and as well as the sample which is under analysis will move along the forward direction, and they will interact with mirrors. The mirrors used in optical in IR spectroscope are used for deflection. So these mirror will deflect incident radiations. And after deflection, the infrared radiation from the mirror will move toward the forward direction toward a device which is known as a beam splitter. This student, please keep in mind that the beam splitter is an optical device, and this beam splitter split the infrared radiation which come from the reference sample and as well as which come from sample under analysis into two separate beams. These beams are usually beam splitter split the radiations in infrared radiation into part 1 and plus part 2. There are two types of beam. Usually the beam which in IR spectrum are splitted into a ratio of 50% plus 50%. So basically beam splitter split the infrared radiation in IR spectroscope into equal parts. However, in instrument you can control a beam splitter and you can control a ratio of splitting of infrared radiation beams. But most commonly the infrared radiation which fall on beam splitter are splitted into two equal parts. So beam splitter will split IR radiations into two equal parts. Beam splitters are divided into four main types. The types of beam splitters are based on the geometry of the beam splitter. One of the common type of beam splitter is known as cube type beam splitter. Second type of beam splitter is known as plate type beam splitter. Third type of beam splitter is known as pellicle beam splitter. And fourth and less common beam splitter type of beam splitter is known as polka dot type beam splitter. So dear student, keep in mind in IR spectroscopy usually beam splitter transmit half of the striking radiation and reflect half of it. So basically this device transmit 50% of the infrared radiation, and whereas it's reflect rest of the 50% of the infrared radiations. So this is an overview of second part of the infrared spectroscope. First part consists of an IR radiation source, beam chopper, monochromator, and some mirrors for reflection. Second part of infrared radiation spectroscope consists of reference sample holding part and sample analysis part, and as well as some mirrors for reflections and a beam splitter, which basically equally divide the IR radiations into striking radiations and as well as reflected radiations. So the incident radiation, which is basically fall, is split into a ratio of 50-50%, and then these incident radiations are then transported, or then they are moved forward to the third part of the infrared spectroscope, known as infrared spectroscope detecting region. So, dear student, from beam splitter, the infrared radiation will move just like this along the forward direction toward a device known as infrared radiation detector. So, this is a third part of the IR spectroscope. Infrared radiation detector will detect the amount of the light transmitted from the IR, amount of the light which is basically transmitted from the reference sample and as well as the sample which is under the analysis. So the detector give us information about the transmitted IR radiation on the basis of a spectrum which is known as infrared radiation spectrum. Infrared radiation spectrum consists of a spectrum based on wave number and transmittance. Transmission is usually from 0 to 100%, whereas the wave number is usually in the range of, it's usually in IR range, okay, around 400,000. So usually in IR spectroscope, the infrared radiations are transmitted. Okay, so the transmitted radiation will in IR radiation spectrum will give us 100% of a line. However, when the infrared radiation is absorbed by some chemical, then the transmission amount of the percentage transmission will be decreased, and in this way the absorption region will appear, and then further, if the wavelength if on another wavelength the infrared radiation is not absorbed, then the transmitted will be 100%. So on the basis of absorption of IR radiation in a specific wavelength give us information about the functional group present in a material, or it give us information to us about that what type of bond is basically present in organic or in inorganic chemical. The detectors used in IR spectroscope are usually different types. Some of the known detectors used in IR spectroscope are bolometer, another type of detector used in IR spectroscope is known as thermocouple based detector. They basically detect the infrared radiation which is transmitted on the basis of the heat. Third type of known detector is based on a photoelectric effect or base detector. Four type of detector used in IR spectroscope is known as pyroelectric detector. The pyroelectric detector detect the transmitted infrared radiation on the basis of pyroelectric effect. So when infrared radiations are detected by transmitted infrared radiations are detected by detector, the detector will interpret the detected transmitted light by a detector will be interpreted by a readout system in a form of a spectrum, which is known as IR spectrum. So on the basis of IR spectrum, we can identify the presence of unknown functional groups in a material. So the unknown functional groups are basically identified in a region, which is a third region, which is based on a detector and readout systems. So now let us conclude the infrared spectroscope in a simple word. Infrared spectroscope device consists of three regions. First region of infrared spectroscope is known as infrared radiation source region. Second region of IR spectroscope is known as sample holding region, and third region of IR spectroscope is known as detection region. First region of infrared spectroscope, which is known as infrared source region, consists of infrared radiation source, optical chopper, mirrors, and monochromators. So the infrared radiation will be produced by infrared radiation infrared source, and then it will be splitted into two parts by an optical chopper, and it will move forward toward a device known as monochromator. So monochromator will select a specific wavelength of an infrared radiation. It will convert a multi-band wavelength of infrared radiation into a single wavelength infrared radiation. Then the single wavelength infrared radiation then will move toward the forward direction into a second part of the IR spectroscope, which is a reference and sample holding region. So the IR toward the reference and sample holding region, and after that the some amount of the infrared radiation will be absorbed by the sample which is under the observation. And however, the reference sample holding region, we usually know their absorption and transmittance wavelength, and after that IR radiation from both the reference and the sample analysis region will move toward the mirrors, and the mirrors will deflect, and they will basically then they will be fall onto a uh, device which is known as a beam splitter. So beam splitter will basically then further split the infrared radiations into two equal parts, and then the IR radiation will move toward the forward direction into a third and final region of IR spectroscope, which is known as a detector. So detector will detect the amount of transmitted radiations from both the reference sample and as well as the sample which is under analysis. Then the radiation which is basically is reached to the detector will further be read to a system known as a readout system, and the readout system will interpret the transmitted radiations from the sample which is under analysis into infrared radiation spectrum. So on the basis of infrared radiation spectrum and on the basis of absorption which is shown by infrared radiation spectrum, we identify functional group and as well as chemical bonding in unknown compound, and on the basis of this we clarify the compound into a list of a known compound, or on the basis of this basically we identify that what compound is a present. So basically this technique will give us a comprehensive information about the presence of or about identification of a functional group present in a chemical.